Welcome, dear friend. Let the day's tensions dissolve like morning mist. Tonight, we're embarking on a gentle journey through the secret world of Herbzo's quiet green beings that have walked alongside humanity since before we built our first shelters, before we planted our first gardens, before we even had words to name them. You pass herbs every day without noticing. They grow in cracks in sidewalks, flourish in forgotten corners, thrive in your spice cabinet. Yet each one holds stories spanning millennia, chemical compositions rivaling any pharmacy, survival strategies that would impress the most brilliant engineers. Tonight, we'll uncover facts so remarkable they seem impossible, yet every single one is true. So settle deeper into comfort. Let your breathing slow to match the rhythm of growing things. If these peaceful discoveries bring you joy, a gentle like helps others find this quiet sanctuary. Subscribe if you'd like more wonder whispered into your evenings. But truly, no pressure, just rest. Let's begin our journey into the hidden garden. Basil can kill bacteria that antibiotics cannot touch. While modern medicine struggles with antibiotic-resistant superbugs, this common kitchen herb produces compounds that destroy bacterial cell walls through completely different mechanisms. Scientists have identified eugenol and linalool in basil essential oils that puncture bacterial membranes like microscopic needles. Bypassing the resistance pathways, bacteria evolved against conventional antibiotics. A plant sitting on your windowsill holds weapons against some of humanity's most dangerous microbial enemies. This antibacterial power isn't recent adaptation. Basil evolved these compounds millions of years before humans existed, defending itself against bacterial infections that threatened leaves and stems. The plant essentially invented its own immune system, crafting molecular weapons through trial and error across countless generations. What works against bacteria attacking basil also works against bacteria attacking us. Evolution, solving the same problem twice, arriving at solutions we're only beginning to understand. Ancient healers knew this intuitively. They didn't understand eugenol or bacterial membranes, but they observed that basil poultices prevented wound infections, that basil tea soothed bacterial stomach troubles. Empirical knowledge, accumulated over thousands of years, confirmed now by electron microscopes and clinical trials. The ancients were right, even if their explanations were wrong. The wisdom survived. Now we know why it worked. Mint can grow a completely new plant from a single leaf. Drop one mint leaf in water and roots emerge within days, transforming a fragment into a whole organism. This vegetative reproduction cloning through leaf cuttings means one mint plant can theoretically become infinite plants. A single ancestor could colonize entire continents through this aggressive self-replication. Its botanical immortality, one individual spreading endlessly through fragmented copies of itself. This explains why mint is nearly impossible to kill. Cut it down and it regrows from roots. Pull it up and mist root fragments sprout new plants. Each piece contains the complete genetic blueprint, ready to regenerate the whole. Gardeners call it invasive, botanists call it successful. Mint doesn't just survive, it conquers, turning every setback into multiplication opportunity. Destruction becomes reproduction. But this aggressive growth serves purpose. Mint evolved in wet, competitive environments, where rapid colonization meant survival. Slow-growing plants got shaded out, outcompeted, eliminated. Mint's strategy was simple: grow faster than everything else, spread farther, occupy every available inch. The plant that could regrow from fragments survived when less resilient species perished. Modern gardens inherit this ancient competitiveness, mint still fighting battles that ended millennia ago. Rosemary contains compounds that improve memory and concentration. The scent alone, specifically the compound 18-cineal, measurably increases cognitive performance in controlled studies. Students smelling rosemary during exams score higher than control groups. The aromatic molecules enter your bloodstream through nasal passages, cross the blood-brain barrier, and enhance neurotransmitter activity in memory centers. A plant native to Mediterranean hillsides, chemically modifying how your brain stores and retrieves information. Shakespeare knew this somehow. Rosemary for remembrance appears in Hamlet, written in 1600 centuries before neuroscience existed. How did Elizabethan England know about rosemary's cognitive effects? Probably through accumulated observation, people noticing they thought more clearly around rosemary, remembered things better when the herb was present. Pattern recognition over generations, cultural knowledge, preserving what worked even without understanding mechanism. Ancient Greek students wore rosemary garlands while studying, believing it helped learning. Medieval scholars kept rosemary on their desks. Renaissance physicians prescribed it for forgetfulness. Across cultures and centuries, independently, humans associated this specific herb with memory. Now we know they were detecting real neurological effects, their brains responding to volatile compounds in ways they couldn't explain but could definitely feel. Intuition meeting chemistry. Chamomile flowers contain a compound chemically similar to Valium. Apigenin, the primary calming component, binds to the same brain receptors as benzodiazepine drugs, producing genuine sedative effects without pharmaceutical intervention. A cup of chamomile tea delivers measurable anti-anxiety compounds, reducing cortisol levels, slowing heart rate, promoting the parasympathetic nervous system's rest and digest mode. It's not placebo, it's pharmacology, delivered through petals instead of pills. This makes chamomile one of the most consumed medicinal plants on Earth. People self-medicating stress and insomnia with a remedy older than written history. The ancient Egyptians offered chamomile to their gods, considering it sacred. The Romans used it to flavor wine and cure insomnia. Germanic tribes considered it one of 9 sacred herbs. Across disconnected civilizations, the same plant found for the same purposes. But chamomile's calming power evolved for the plant's benefit, not ours. These compounds likely deterred insect herbivores, disrupting their nervous systems enough to discourage feeding. The sedative effect that soothes human anxiety originally evolved as insect deterrent. We're experiencing a plant's defensive chemistry, repurposed through human ingenuity into medicine. The sword becomes medicine when wielded gently. Thyme produces more essential oil per leaf than almost any other plant. Up to 2.5% of thyme's fresh weight is pure essential oil thymol and carvacrol, compared to 0.1% in most aromatic plants. This makes thyme extraordinarily potent. Its scent detectable from remarkable distances. Its antimicrobial effects measurable at minuscule concentrations. A few thyme leaves contain enough active compounds to sterilize surfaces, preserve food, kill mold and bacteria. This concentration made thyme invaluable before refrigeration. Ancient Sumerians used thyme in beer brewing, preventing bacterial spoilage. Egyptians used it in embalming, the antimicrobial oils preserving tissue. Medieval Europeans scattered thyme on floors, the crushed leaves releasing antiseptic compounds that reduced household disease transmission. The herb was functioning as antibacterial agent, air purifier, and preservative simultaneously, a chemical factory in leaf form. Modern research confirms thyme oil kills antibiotic-resistant bacteria, including MRS, methicillin-resistant Staphylococcus aureus, one of medicine's most feared superbugs. Hospital cleaners now sometimes use thyme-based disinfectants, returning to botanical solutions as synthetic antibiotics fail. Ancient technology becoming cutting edge again. The plant that preserved Bronze Age beer might help solve 21st century antibiotic resistance. Time is circular. Solutions return. Lavender can slow your heart rate measurably. Clinical studies show lavender scent reduces heart rate by 3 to 5 beats per minute within minutes of exposure, lowers blood pressure, decreases stress hormone, cortisol concentrations in saliva. The compound linalool enters bloodstream through inhalation, affecting the autonomic nervous system, the automatic controls, managing heart, breathing, digestion. A purple flower reaching into your body's control systems, adjusting settings to ward.com. This is why lavender appears in sleep products everywhere. Pillows, sprays, candles, sachets. Entire industries built on one plant's sedative chemistry. But humans didn't invent this use. Historical records show Romans perfuming bathwater with lavender. The name derives from lavare, to wash. They noticed it made baths more relaxing, sleep easier afterward. 1500 years later, we measure the neurological mechanisms and confirm they were absolutely right. Victorian ladies carried lavender smelling salts for fainting spells. Not superstition, the scent genuinely affects blood pressure and consciousness. When someone fainted from corseted breathing restrictions, lavender helped restore normal cardiovascular function through its direct effects on the nervous system. They lacked our vocabulary for describing it, but they correctly identified a plant that modifies human physiology through aromatic compounds. Observation preceding explanation. Cilantro tastes like soap to 14% of humans due to a specific genetic variation. The OR6A2 gene determines whether you taste cilantro's pleasant citrus notes or detect aldehydes, the same compounds in dish soap and stink bugs. This isn't preference, it's genetic destiny, written in DNA, determining your relationship with this herb before you're born. Some people are genetically constructed to hate cilantro, their taste receptors shaped differently from birth. This reveals how subjective taste truly is. You and someone else can eat identical cilantro, but you're having fundamentally different sensory experiences determined by genetics. They taste lemon and brightness. You taste industrial cleanser. Same molecules, different receptors, opposite realities. It's a reminder that sensory experience isn't universal. We each inhabit slightly different perceptual universes, especially regarding taste. Interestingly, cilantro preference shows geographic patterns. Asian, Middle Eastern, and Latin American populations show lower rates of the soap-tasting gene, probably because these cultures used cilantro for millennia, and those who could tolerate it had nutritional advantages, gradually shifting allele frequencies over generations. Europeans rarely used cilantro historically and show higher rates of the soap-detecting gene, evolution operating through cuisine, taste adapting to cultural diet across centuries. Parsley is one of the most difficult herbs to germinate from seed. The seeds can take 3 to 6 weeks to sprout, compared to basil's 5 days, leading to the medieval saying, "Parsley seeds go to the devil and back 9 times before sprouting." The trinstream delay happens because parsley seeds contain germination inhibitors that must break down before the embryo can grow, a protective mechanism preventing premature sprouting during brief, warm spells in parsley's native Mediterranean climate. This frustrates gardeners, but serves brilliant evolutionary strategy. Parsley evolved in environments with unpredictable spring weather, warm days, followed by killing frosts. Seeds sprouting immediately would die when cold returned. The germination delay ensures sprouting only happens after sustained warmth, when spring has truly arrived and the seedling can survive. The plant essentially waits to be certain, trading speed for reliability. Ancient herbalists interpreted this delay spiritually. They believed parsley seeds traveled to the underworld and back, gathering magical properties during the journey. The truth is equally magical. Chemical time locks encoded in seed coats, molecular switches that respond to environmental conditions, ensuring birth happens only when survival is probable. The seeds weren't visiting the devil. They were waiting for spring to prove itself. Dill can grow 5 feet tall in a single season, from tiny seed to towering plant in 4 months. Dill demonstrates explosive growth that seems almost impossible. This rapid biomass production requires extraordinary nutrient uptake and photosynthetic efficiency. The plant is converting sunlight, water, and air into solid matter at remarkable speed, building complex structures from basic elements faster than most garden plants can manage. This growth rate evolved as competitive strategy. Dill grows in disturbed soils, roadsides, field edges, abandoned areas where many plants compete for space. Growing tall quickly means capturing sunlight before neighbors shade you out, flowering before the growing season ends. It's a race against time and competitors, and dill wins through sheer growth velocity. The fastest organism claims the resources, but this speed comes with fragility. Dill's stems are relatively weak. All that growth happens so fast, the structural tissues can't fully strengthen. Strong winds can flatten mature dill that grew too quickly to build robust support systems. It's a calculated risk: grow fast and risk collapsing, or grow slowly and definitely get shaded out. Dill chose speed, accepting that some plants will fall, but enough will survive to reproduce. Better to risk failure through boldness than guarantee it through caution. Sage has been used continuously for at least 4,000 years. Cuneiform tablets from ancient Mesopotamia describe sage use in medicine and ritual. Egyptian papyri mention it. Chinese medical texts from 2,000 years ago document sage tea for longevity. This herb has been gathered, cultivated, dried, and consumed across for millennia of human civilization, surviving the rise and fall of empires, persisting through cultural changes that swept away countless other traditions. This longevity suggests genuine efficacy. Practices that don't work tend to disappear over generations, replaced by more effective alternatives. Sage persisted because it worked, reducing sore throats, improving memory, aiding digestion. Modern research confirms sage contains rosmarinic acid and other compounds with anti-inflammatory and antioxidant properties. Ancient healers were right. They just lacked our vocabulary for explaining why. The name sage comes from Latin salvere, to save, to heal. The Romans considered it capable of curing almost anything. granting near magical healing status. We'd call that exaggeration now, but the core insight was sound. This plant contains multiple bioactive compounds affecting various body systems. Not a cure-all, but genuinely therapeutic across multiple conditions. The ancients inflated the truth, but didn't invent it. Oregano oil is more effective than some antibiotics against certain bacteria. Laboratory studies show oregano essential oil, particularly carvacrol and thymol, destroys E. coli, salmonella, and listeria at concentrations where some antibiotics fail. The oil literally dissolves bacterial cell membranes, a mechanism bacteria cannot develop resistance against because it's not targeting specific proteins, but attacking the fundamental structural integrity of the cell. This makes oregano potentially valuable as antibiotic resistance worsens. Bacteria evolve resistance by modifying the proteins antibiotics target, but they cannot tisely develop resistance to having their cell walls dissolved. It's the difference between picking a lock and melting the door. Oregano chooses door melting, a crude but highly effective approach bacteria struggle to defend against. Ancient Greeks used oregano for this without knowing the chemistry. They applied oregano poultices to wounds, drank oregano tea for digestive infections, used it to preserve food. They observed that oregano-treated conditions improved more often than untreated ones, accumulating empirical evidence that this particular plant had medicinal value. Now we can measure the minimum inhibitory concentration and identify the active compounds, but the fundamental observation organophytes infections was correct thousands of years before germ theory existed. Tarragon contains a compound that numbs taste buds. Estragole, the primary component, temporarily reduces taste sensitivity, which is why tarragon is traditional in French cuisine. It mellows stronger flavors, creates subtle complexity, allows delicate tastes to emerge. Chefs use it intuitively, not realizing they're employing a mild anesthetic that modifies diners' sensory experience at a neurological level. This numbing effect evolved as herbivore deterrent. Insects and animals that ate tarragon experienced reduced taste sensation, making food less appealing, discouraging further feeding. The plant essentially confused predators' sensory systems, making itself taste like nothing, therefore undesirable. Humans repurposed this defensive chemistry into culinary sophistication, the plant's weapon becoming our flavor tool. Interestingly, tarragon loses this property when heated extensively. The estragole breaks down at high temperatures, which is why French cooking often adds tarragon near the end of cooking or uses it fresh. The timing isn't just tradition, it's practical chemistry, preserving the compounds that make tarragon special. Culinary tradition, encoding chemical knowledge, recipes, preserving molecular understanding their creators couldn't name. Chives are the only herb in the allium family that grows wild on every continent except Antarctica and Australia. This remarkable distribution means chives adapted to tundra, temperate forests, grasslands, mountains, nearly every terrestrial ecosystem Earth offers. The plant's flexibility is extraordinary, surviving Arctic winters and temperate summers, thriving in diverse soils, reproducing in varied conditions. Few plants show such cosmopolitan success. This adaptability comes from chives' hybrid reproductive strategy. They produce seeds for genetic diversity and spread to new areas, but also reproduce vegetatively through bulb division, cloning themselves for local multiplication. This combination means chives can both adapt to new environments through sexual reproductions genetic shuffling, and rapidly exploit favorable conditions through asexual multiplication. Best of both strategies, deployed as conditions require. Indigenous peoples across the Northern Hemisphere independently discovered chives and incorporated them into cuisine and medicine. Separate cultures on different continents found the same plant useful, suggesting chives have inherent properties humans consistently value. The mild onion flavor, the nutritional content, the antimicrobial effects. When disconnected peoples arrive at identical conclusions, you're probably observing something genuine about the plant, not cultural coincidence. Fennel seeds can remain viable for decades. Seeds stored properly, cool, dry, dark can germinate successfully after 30 to 40 years. Their embryos suspended in metabolic near-death, waiting patiently for conditions favoring growth. This longevity means a single good seed year can sustain fennel populations through decades of poor reproduction. The seeds are botanical time capsules, bridging environmental gaps. This dormancy requires sophisticated biochemistry. The seed must maintain DNA integrity while essentially remembering, preserve cellular machinery through years of inactivity, then restart complex life processes when planted. It's like freezing a computer for decades, then booting it up perfectly. The fact that this works at all is remarkable. That it works for 40 years is almost miraculous. Ancient peoples understood this intuitively, storing fennel seeds as long-term food security. Archaeological digs find fennel seeds in Bronze Age storage jars, medieval monasteries, colonial homesteads. The seed's longevity made it reliable food source and medicine bank. Plant it this year, or in 10 years, it'll still grow. Biological insurance against uncertain futures. Lemon balm is in the mint family, though it tastes nothing like mint. This illustrates how plant families can produce wildly different chemical profiles while sharing structural similarities. Lemon balm evolved citral and citronelle lemon-scented compounds, while other mints evolved menthol and menthon, same family, completely different defensive chemistry, demonstrating evolution's creativity within genetic constraints. This chemical diversity within families shows how plants experiment with survival strategies. The mint family's basic structure, stems, opposite leaves, aromatic oil scan house countless different volatile compounds. Each species evolved unique chemistry matching its specific ecological challenges. Lemon balm's lemon scent deters different herbivores than peppermints, menthol, allowing related plants to occupy slightly different ecological niches without direct competition. Medieval monks cultivated lemon balm extensively, calling it the elixir of life. They observed it attracted bees, prolifically. The genus name, Melissa, comes from Greek for honeybee. The plant produces nectar rich in specific sugars bees prefer, establishing mutualistic relationship. Bees get food, lemon balm gets pollinated, two species cooperating across the kingdom divide, each making the other's survival more likely. Evolution, creating partnerships. Bay leaves come from trees that can live 500 years. A single bay laurel, planted during the Renaissance, could still be producing leaves today. The same individual organism, providing flavor across 5 centuries. This longevity means some European bay trees witnessed the transition from hand-grinding spices to industrial food processing, from wood-fired ovens to microwave meals, standing quietly in courtyards, while human civilization transformed around them. This extreme lifespan requires extraordinary durability. The tree must resist centuries of pests, diseases, weather extremes, human disturbance. Bay laurels evolved thick, leathery leaves filled with protective essential oils that deter insects and fungi. These same compounds eucalypol, cineol make bay leaves valuable culinary herbs. The tree's defensive chemistry became our flavor enhancement. Protection and cuisine intertwine. Ancient Greeks crowned victors with bay laurel wreaths, establishing a tradition surviving into modern Olympic Games. The laurel in poet laureate, baccalaureate degree all reference this tree, honoring achievement with botanical symbols. A single species becoming metaphor for excellence across multiple civilizations. Its leaves representing victory for 3,000 years. Few plants achieve such cultural prominence. Continuing Part 1. Ginger isn't technically an herb, it's a rhizome, an underground stem. This distinction matters because stems store more energy than leaves, making ginger extraordinarily nutrient-dense. The rhizome accumulates starches, sugars, and bioactive compounds in concentrations impossible in aerial tissues. When you consume ginger, you're eating condensed plant energy, months of photosynthesis compressed into pungent flesh. This storage strategy evolved for survival in seasonal climates. Ginger grows in tropical areas with distinct wet and dry seasons. The rhizome lets the plant survive drought. The above-ground portions die back, but the rhizome underground waits, protected from heat and water loss, ready to rest prout when rains return. Its biological patience, dormancy as strategy, the plant hiding underground until conditions improve. Humans discovered ginger at least 5,000 years ago. Ancient Chinese and Indian medical systems both incorporate ginger extensively, suggesting independent discovery of its properties. The compound zingaroni responsible for ginger's bite reduces nausea, settles stomachs, eases inflammation. Sailors chewed ginger for seasickness. Pregnant women used it for morning sickness. Elderly people took it for arthritis. One rhizome addressing multiple ailments through diverse bioactive compounds. Turmeric contains curcumin, which gives it that brilliant yellow color and also happens to be a powerful anti-inflammatory. This compound reduces inflammation markers in blood tests as effectively as some NSAIDs, non-steroidal anti-inflammatory drugs, without the side effects. A root that stains everything it touches also modulates immune system function, reducing the chronic inflammation underlying arthritis, heart disease, possibly cancer. But there's a catch. Curcumin has terrible bioavailability. Your digestive system barely absorbs it, most passes through unchanged, unless you combine it with black pepper. The piperine in black pepper increases curcumin absorption by 2,000%, not a typo, 2,000%. Indian curry, combining turmeric and black pepper, isn't just traditional, it's sophisticated pharmacology, maximizing medicine through food pairing. This knowledge developed empirically. Ancient Ayurvedic practitioners observed that turmeric worked better when combined with other spices, preserving these combinations in traditional recipes without understanding molecular mechanisms. Modern science reveals why the combinations work, confirming that traditional wisdom, derived from observation across generations, captured real biochemical synergies. The curry recipe is chemical formula disguised as cuisine. Catnip affects roughly 50 to 70% of cats, creating euphoric response through nepetalactone binding to feline olfactory receptors. But the same compound repels mosquitoes more effectively than DEET in some studies. one molecule triggering opposite responses in different species: ecstasy for cats, repulsion for insects. The plant evolved nepetalactone as insect deterrent. Cats' unusual response is evolutionary coincidence, their pleasure centers accidentally responding to mosquito repellent. This creates the amusing situation where mosquito repellent plants make cats blissfully happy. The universe has no obligation to make sense. And here's proof: a plant's defensive chemistry creating euphoria in a completely unrelated species for no adaptive reason. Evolution produces these odd intersections, unintended consequences where one species' solution creates another species' recreational drug. Non-responsive cats lack the specific receptor configuration triggering catnip response. It's genetic: you either have the sensitivity or you don't, determined before birth, unchangeable. About 30% of cats can smell catnip but feel nothing. Like humans, genetically unable to smell asparagus in urine or taste bitterness in Brussels sprouts. Genetic lottery determining your relationship with specific molecules forever. Horseradish produces its sinus-clearing pungency only after being grated or cut. The intact root is relatively mild because the compound allyl isothiocyanode doesn't exist in the living tissue. Instead, the plant stores two separate chemicals, glucosinolates and the enzyme myrosinazine, different cellular compartments. When you cut the root cells, rupture, chemicals mix, enzyme activates glucosinolates, and suddenly you're crying from vapors that didn't exist 30 seconds earlier. This is chemical warfare with a timer. The plant keeps its weapons disassembled until damage occurs, then instantly manufactures irritating compounds that deter whoever's attacking. Its brilliant defense: no energy wasted producing compounds until actually needed. No risk of the plant poisoning itself with its own weapons. Damage triggers synthesis, assembly happening in real time. Humans eat this deliberate irritant for pleasure, seeking the sinus-opening, terror-inducing experience. We've turned plant defensive chemistry into condiment, intentionally triggering the plant's chemical weapons because we enjoy the sensation. This is possibly unique to humans deliberately consuming things that hurt us because we find the pain interesting. Cognitive sophistication meeting masochism. Stevia is 200 to 300 times sweeter despite containing 0 calories. The steviol glycosides, sweet compounds in stevia, leaves bind to sweet taste receptors on your tongue just like sugar does, triggering identical sensory experience. But your body cannot metabolize these compounds for energy. They pass through undigested, providing sweetness without calories, taste without nutrition. This creates biological paradox. Your tongue reports sweet energy available, but your metabolism receives nothing. The disconnect can confuse hunger signals, insulin responses, satiety mechanisms. You're experiencing sensory input your body associates with calories, but the calories never arrive. It's sensory spoofing, fooling ancient systems that evolved assuming sweetness always meant sugar, always meant energy. Indigenous Guarani peoples of Paraguay used stevia for 1,500 years, sweetening mate tea with leaves, understanding empirically that this particular plant provided sweetness without negative effects. They couldn't explain glycosides or receptor binding, but they correctly identified a plant providing desired taste without the consequences of honey or fruit. Observation leading to adoption. Utility preserving knowledge. Garlic is technically 99% the same plant as an onion, yet tastes completely different. The genetic variation is minuscule, They're both allium species, sharing nearly identical DNA, but that tiny difference produces entirely distinct sulfur compounds. Garlic makes allicin. Onions make different thiosulfonates. 1% genetic variation creating flavor profiles so different you'd never guess they're botanical cousins. Small changes, enormous consequences. This demonstrates how tiny genetic tweaks produce dramatic results. The same genes, slightly differently regulated, slightly modified, create divergent chemistry from nearly identical blueprints. It's like two recipes using the same ingredients in slightly different proportions, producing completely different dishes. The genome is less instruction manual and more improvised jazz, small variations, creating infinite diversity. Ancient peoples cultivated both garlic and onions for millennia without knowing their genetic similarity. They simply observed, this plant, with separate cloves, has strong flavor and medicinal properties. This plant with concentric layers has milder flavor and stores well. The kinship was invisible until modern genetics revealed it. Sometimes the relationships matter less than the differences, even when the differences are statistically tiny. Marjoram is sweet organo's gentle cousin, containing similar compounds but in different ratios. Where organo is bold and pungent high in carvacrol, marjoram is subtle and sweet higher in terpenen. This chemical shift creates entirely different culinary personalities from related plants. Same family, different proportions, divergent reputations. The recipe is everything. Ingredients matter less than ratios. This relationship confused herbalists for centuries. Ancient texts often conflate marjoram and oregano, treating them as varieties of the same plant rather than distinct species. They're not entirely wrong. Botanically, they're extremely close, easily hybridizing, producing fertile offspring. The distinction is real but blurry. A reminder that nature doesn't always honor our neat categories. Plants exist on continuums. We impose boundaries. Greek mythology held that Aphrodite created marjoram, bestowing it with gentle, love-promoting properties, contrasting with oregano's more aggressive nature. Scientifically baseless, but it captures something true. These similar plants feel different, inspire different uses, evoke different responses. The mythology expresses botanical reality through metaphor, encoding actual differences in poetic language. Sometimes, myth preserves truth better than literal description. Chervil loses almost all flavor when dried. Unlike most herbs, the delicate compounds responsible for chervil's anise-like taste estragoli and methyl chavicol, extraordinarily volatile, evaporating almost completely during drying process. What remains tastes like dried grass. The botanical essence vanished. This makes chervil unique. Among culinary herbs, must be used, fresh or not at all. This volatility explains why chervil never became globally traded spice. Herbs that dry well, oregano, thyme, bay, traveled trade routes, reaching markets worldwide. Chervil stayed local, appearing only in cuisines with access to fresh plants. Its chemistry determined its historical distribution. The compounds that make it delicious also made it economically unsuitable for long-distance commerce. Biology became destiny. French cuisine celebrates this ephemerality, using chervil fresh in fines herbs, knowing the flavor exists temporarily, appreciating its transience. There's wisdom. There's some things cannot be preserved, only experienced in the moment. Chervil teaches impermanence through flavor, a botanical meditation on accepting what cannot be stored or saved. Enjoy it now or lose it forever. Angelica grows up to 8 feet tall with stems thick as broomsticks. This biennial herb saves all its energy for one explosive second year, growing from small rosette to towering giant in a single season before flowering and dying. Its botanical kamikaze reproduce spectacularly once, then perish. The strategy works. One Angelica plant produces thousands of seeds, ensuring genetic survival even as the parent dies. This biennial life cycle confuses gardeners expecting annual regrowth. First year, modest leaves, no flowers, disappointing. Second year, massive growth, spectacular flowering, then death. Understanding the cycle is crucial. Harvesting roots after first year captures maximum medicinal compounds before the plant diverts energy to reproduction. Traditional herbalists knew this timing intuitively. Modern phytochemistry confirms their harvesting calendars were optimized for compound concentration. Medieval Europeans considered Angelica divinely blessed, naming it after archangels, believing it protected against plague. Probably not divinely inspired, but the root does contain antibacterial coumarins and immune-stimulating polysaccharides. The plague protection was wishful thinking, but the underlying observation Angelica has medicinal value was sound. Faith mixed with pharmacology, desperation, generating testable hypotheses. Borage flowers are edible and taste like cucumber, despite being completely unrelated to cucumbers botanically. Both produce similar volatile compounds, mainly aldehydes, through convergent evolution. Two unrelated plants solving different problems arrived at identical chemistry. Borage deters herbivores with cucumber-scented oils. Cucumbers attract pollinators with similar compounds. Same molecules, different purposes, separate evolutionary paths, reaching the same chemical destination. This convergence demonstrates that useful chemical solutions get discovered multiple times independently. Evolution explores chemical space, and certain compounds work so well they emerge repeatedly in unrelated lineages. Like how eyes evolved separately in octopi and vertebrates different anatomies, implementing the same functional solution. Chemistry has optimal answers, and natural selection finds them repeatedly. Borage flowers are intensely blue from anthocyanins that change color with pH blue in neutral conditions, pink in acid, purple in alkaline. The petals are living pH indicators, their color reflecting soil chemistry. Gardeners can roughly assess soil acidity by watching borage flowers shift color through the season as soil conditions fluctuate. The plant becomes environmental sensor, broadcasting soil status through petal pigmentation. Lovage tastes strongly of celery, yet isn't celery. Another case of unrelated plants producing similar flavors. The compound responsible phthalate appears in both, evolved independently, creating flavor convergence across plant families. This means if you need celery flavor but lack celery lovage, substitutes perfectly chemically. Different species, interchangeable chemistry. This made lovage valuable in medieval European cuisine, where celery wasn't yet cultivated. Lovage grew reliably in northern climates, providing the desired flavor without importing Mediterranean vegetables. It was regional ingredient, meeting local needs through coincidental chemistry. Geography dictated diet. Plants adapted to local conditions determined available flavors. Lovage also concentrates flavors when dried. Unlike most herbs that fade, the phthalates intensify during dehydration, making dried lovage stronger than fresh opposite the usual pattern. This unusual property made lovage practical for winter storage, one of few herbs that improved when preserved. Winter cooking relied on this quirk, dried lovage providing concentrated flavor through cold months when fresh herbs were impossible. Savory comes into varieties summer and winter with different growing habits, but nearly identical chemistry. Summer savory is annual, dying after one season. Winter savory is perennial, returning year after year. Yet both produce carvacrol and thymol in similar concentrations, creating comparable flavors from different life cycles. Evolution duplicated the chemistry while varying the timing. This duplication let traditional cooks choose based on garden design rather than flavor. Want herb returning annually? Plant winter savory. Prefer replanting yearly? Choose summer savory. The flavor stays constant. Only the relationship with time changes. It's rare botanical flexibility, nature offering options without flavor trade-offs. Ancient Romans considered savory sacred to satyrs, mythological half-goat creatures representing virility and wilderness. The herb's reputation as aphrodisiac persisted through millennia, likely because its pungent, peppery taste suggested strength and vitality. No actual aphrodisiac compounds exist in savory, but the flavor associations created persistent cultural meanings. Taste became metaphor, became mythology, became tradition. Epazote is essential in Mexican cuisine, but virtually unknown elsewhere, despite growing wild across the Americas. This geographic flavor isolation happened because epazote contains a scaradola compound that's simultaneously flavoring agent and intestinal parasite treatment. Mexican cooking traditions evolved using epazote, specifically with beans, because it reduces gas formation while killing parasites common in pre-refrigeration eras. This dual-purpose flavor and medicine created culinary medical fusion. The recipe becomes prescription, the meal becomes treatment. Traditional Mexican cooks weren't separating cuisine from healthcare. Food was medicine, medicine was food. Epazote exemplifies this integration perfectly. You eat it because it tastes good and coincidentally addresses digestive problems. However, ascaridole is toxic in large doses, meaning epazoto requires careful use. Traditional recipes call for specific amounts developed through generations of trial and error, finding the dose that helps digestion without causing harm. It's empirical pharmacology encoded in grandmother's cooking, precise dosing disguised as pinches and handfuls. The recipe is safety protocol. Lemongrass contains citral concentrations up to 85% of its essential oil content, far higher than actual lemons. This makes lemongrass more intensely lemon-flavored than lemons themselves, a grass out-lemoning the fruit that owns the flavor name. The plant evolved extreme citral production as insect deterrent. Humans repurposed this defensive excess as culinary concentrate. This intensity made lemongrass valuable in cuisines where lemons weren't native. Southeast Asian cooking developed around lemongrass, accessing citrus flavors without citrus fruits. The grass provided what the region's climate couldn't grow: tropical heat favoring lemongrass over temperate citrus trees. Geography shaped cuisine through botanical availability. Lemongrass also repels mosquitoes as effectively as many commercial repellents, the citral disrupting mosquito olfactory receptors. Traditional tropical housing often included lemongrass plantings around foundations, creating mosquito barriers through landscaping. Architecture integrated pest control through strategic planting, design and biology collaborating. The garden becomes defense system. Mugwort is one of the most widespread plants on Earth, growing on every continent except Antarctica. This cosmopolitan distribution suggests extraordinary adaptability. Mugwort thrives in deserts and wetlands, Arctic tundra and tropical highlands, disturbed urban lots, and pristine wilderness. Few plants show such environmental flexibility, such indifference to climate and soil. This success comes from mugwort's hybrid reproductive strategy and allopathic chemicals that inhibit competing plants. Mugwort releases compounds into soil that stunt nearby species growth, chemical warfare, clearing space for its own expansion. It's botanical imperialism, using chemistry to claim territory, eliminating competition through underground poisoning. But mugwort also has complex relationship with human consciousness. The herb appears in dream pillows across multiple cultures, European, Asian, indigenous American, with users reporting more vivid dreams. Contains thujan, a compound that modulates GABA receptors, potentially affecting dream states. Whether this objectively increases dream recall or works through expectation remains scientifically unclear. But the cross-cultural observation pattern suggests something real, even if mechanisms stay mysterious. Hyssop in the Bible probably isn't the hyssop you can buy today. Biblical hyssop, used in purification rituals, was likely marjoram or organoplants native to the Middle East. Modern garden Hyssopus opus, Officinalis European, not present in ancient Israel. Somewhere across millennia and translations, the names shifted, divorced from original plants, creating botanical mistaken identity lasting 2,000 years. This confusion demonstrates how plant knowledge transfers imperfectly across time and culture. Names stay constant, while reference change. Translations assume equivalent plants exist in new regions. The ritual described in Exodus used specific herbs with specific properties, but those properties got attributed to whatever plant inherited the name in later contexts. The recipe stayed, ingredients changed. No one noticed. Despite the confusion, modern hyssop has genuine medicinal properties: antiseptic oils, expectorant compounds, anti-inflammatory effects, different plant, similar utility. Maybe the name transfer wasn't entirely accidental. Perhaps medieval herbalists recognized similar properties in European hyssop and deliberately reused the biblical name. Knowledge transmission through strategic renaming. Sorrel contains oxalic acid, the same compound that makes rhubarb leaves toxic. But sorrel leaves contain much lower concentrations, making them safely edible in normal quantities. The difference between medicine and poison is dose, and sorrel demonstrates this principle perfectly. Small amounts provide tart flavor and vitamin C. Large amounts cause kidney problems. Location on the dosage curve determines whether something nourishes or harms. This oxalic acid creates sorrel's characteristic sour taste, sharp and lemony, without citrus. Medieval Europeans used sorrel extensively before citrus fruits became available, the oxalic acid providing acidity in cooking. It's another case of local plants substituting for unavailable imports. Regional ingredients meeting culinary needs through chemical coincidence. Sorrel also accumulates in soil seasonally highest concentrations in spring growth, declining through summer. Traditional harvest timing developed around this, gathering sorrel early when tender and less acidic, avoiding late-season leaves with uncomfortable oxalate levels. The calendar became dosage guide, seasonal knowledge, encoding safety information. Cardamom is the world's third most expensive spice by weight after saffron and vanilla. This price reflects cultivation difficulty. Cardamom grows only in specific tropical conditions, requires 3 years before first harvest, produces modest yields from labor-intensive hand harvesting. Each step adds cost. The complexity accumulates into expensive spice. But expense also reflects unique chemistry. Cardamom's flavor, profile eucalyptol, terpenyl acetate, linalool is irreproducible by other spices. You cannot substitute cardamom. Nothing else tastes remotely similar. This uniqueness maintains demand despite price. When only one ingredient works, you pay what it costs. Ancient Arabian traders created elaborate deceptions about cardamom's origins, claiming it grew in terrifying mountains guarded by poisonous snakes, justifying exorbitant prices through fabricated danger. The reality grows in Indian forests. No snakes was less dramatic, but still challenging enough to maintain high value. Lying about details while preserving underlying truth. It's expensive because it's difficult. Bergamot orange provides the distinctive flavor in Earl Grey tea, but it's not technically an herb, it's a citrus fruit. However, the leaves and flowers also contain aromatic oils used medicinally, blurring the herb-fruit distinction. Bergamot demonstrates how botanical categories are human constructs imposed on nature's continuum. The plant doesn't care whether we call it herb or fruit. It just grows. The bergamot variety used in tea Citrus bergamia grows almost exclusively in Calabria, Italy. The specific terroir climate soil altitude produces optimal oil composition found nowhere else. Attempts to cultivate it elsewhere produce bergamot, but with subtly different chemistry, altered flavor. Place becomes ingredient, geography written into molecular structure. Bergamot oil also contains bergapin, a compound causing photosensitivity. Skin exposure plus sunlight equals burning and blistering. Perfumes containing bergamot oil once caused bergamot oil dermatitis, mysterious skin reactions that took years to trace to bergamot plus sun exposure. The chemistry that makes bergamot smell beautiful also makes skin vulnerable to light. Beauty and danger in the same molecule. Hops are related to cannabis, both members of the Cannabaceae family. They share terpene profiles, producing similar aromatic compounds despite different uses. Hops evolved bitter acids for defense. Cannabis evolved cannabinoids, but both produce myrcene, caryophyllene, and other terpenes, creating aromatic overlap. Cousins solving different survival problems with partially shared chemistry. This relationship surprises people who associate cannabis with intoxication and hops with beer. But hops have mild sedative properties used medicinally in sleep pillows and anxiety teas. The compounds that make beer bitter also promote relaxation. The plant defending itself against herbivores inadvertently creates human sedation. Defense chemistry repurposed as sleep aid. Female hop flowers produce the resins brewers want, making hops commercially unusual. Only females matter. Males are discarded or eliminated. This creates all-female hop yards, vegetatively propagated clones stretching across acres. Genetic uniformity trading diversity for predictable chemistry. Agriculture selecting one sex, rejecting the other, creating single-gender botanical populations. Wormwood contains thujon, the supposedly hallucinogenic compound in absinthe that led to the spirit's early 1900s ban. Except thujon isn't actually hallucinogenic at concentrations in absinthe. The madness was probably alcoholism combined with copper contamination in poorly made spirits. Wormwood was blamed for effects it didn't cause, demonized through misunderstanding and moral panic. This created lasting mythology around absinthe and wormwood, persecution based on false chemistry. Modern analysis shows historical absinthe contained 25 milligrams L-thugenfar, below levels causing neurological effects. The green fairy wasn't wormwood, it was extreme alcohol content, plus suggestion, plus poisonous additives. The plant was innocent, convicted through association. Yet wormwood does have genuine medicinal properties. Artemisinin derivatives treat malaria more effectively than older drugs, saving millions of lives. The same plant, falsely accused of causing madness, provides crucial anti-malarial medicine, vindication through different chemistry, redemption through unrelated compounds. Wormwood's reputation reversal from dangerous intoxicant to life-saving medicine demonstrates how scientific understanding transforms botanical narratives. Valerian root smells terrible, like sweaty gym socks, because of isovaleric acid, the same compound creating aged cheese and body odor smell. Yet this foul-smelling root is powerful sedative, containing valerianic acid that modulates GABA neurotransmitters, promoting sleep and reducing anxiety. The sleep aid smells like the insomnia it treats. Olfactory irony, creating compliance problems. Effective medicine that patients struggle to take because it smells like what they're trying to escape. This disconnect between smell and function appears frequently in medicinal plants. Evolution optimized for deterring herbivores, not appealing to humans. Many potent medicines smell or taste terrible precisely because those characteristics prevent animals from consuming them. We force ourselves through disgust to access healing, overriding sensory warnings with cognitive determination. Ancient peoples drank valerian tea despite the smell, preserving knowledge that this particular awful-smelling root helped sleep. The effectiveness had to be dramatic enough to overcome the smell, suggesting genuine pharmacological effects. Placebo wouldn't survive that sensory barrier. Only real results could sustain use across generations, despite olfactory punishment. Sweet woodruff contains coumarin, which smells like fresh-cut hay and vanilla. But coumarin only develops when the plant dries. Fresh woodruff has little scent. The compound forms when glucosides break down during drying, creating delayed aromatic emergence. The plant doesn't smell until after harvest, chemistry appearing through death and dehydration. This delayed scent made woodruff valuable for storing among linens and clothes, where it slowly released pleasant aroma as it dried. Medieval Europeans scattered dried woodruff in churches on feast days, the crushed plants releasing coumarin as worshippers walked over them, scent becoming ceremony, chemistry creating ritual atmosphere. Coumarin also has anticoagulant properties, blood-thinning effects, which makes sweet woodruff medicinally significant, but also potentially dangerous in large doses. Traditional recipes using woodruff in May wine employed small amounts developed through trial and error, finding the dose that flavored without causing bleeding disorders. The recipe is safety protocol again. Grandmother's measurements, encoding pharmacological precision. Capers aren't herbs, but flower buds, specifically from Capara spinosa, a thorny shrub growing wild across Mediterranean cliffs. The buds must be hand-picked before flowers open, then cured in salt or vinegar, labor-intensive process, creating expensive ingredient. Each caper represents human labor applied to specific developmental moment, timing critical to capturing the desired flavor. This timing specificity made caper harvesting specialized knowledge. Pick too early and buds lack flavor. Pick too late and flowers open, becoming inedible. The window is narrow, requiring daily monitoring, experienced judgment, quick action, skills developed over lifetimes, passed through apprenticeship, preserved in families for generations. Capers also contain quercetin and other flavonoids at concentrations rivaling any vegetable, making them unexpectedly nutritious despite tiny serving sizes. The compounds that make capers shelf-stable through pickling salt and acid also preserve the antioxidants. Preservation method maintaining medicinal properties, cuisine and pharmacy coinciding. Cumin seeds aren't actually seeds, but fruit seed is dried fruit containing the actual seed inside. This technical distinction matters less than the fact that cumin has been traded continuously for at least 4,000 years, appearing in Egyptian tombs, biblical texts, Roman recipes, medieval spice markets. Few commodities show such sustained commercial importance across millennia. This longevity stems from cumin's unique flavor, impossible to replicate with other spices and digestive benefits. Cuminaldehyde, the primary aromatic compound, also stimulates digestive enzyme secretion, genuinely aiding digestion. The flavor people wanted came bundled with medicinal effects they noticed even without understanding mechanisms. Cumin also demonstrates price volatility in historical spice trade. Wars interrupted supply, droughts reduced harvests, political changes rerouted trading, disruption sent prices soaring. Medieval European household accounts show cumin prices varying 400% year to year. Wealthy families hoarding it during cheap years, poor families doing without entirely during expensive years. The spice that flavored food also indicated economic status. Bay laurel leaves are toxic, fresh, but safe, dried. The toxicity primarily from essential oils in high concentrations decreases as oils volatilize during drying. Fresh bay is chemically similar to dried bay except for oil concentration, making the difference between seasoning and mild toxin one of drying time. Processing converts poison to flavor, time transforming danger into safety. This transformation explains why recipes specify dried bay leaves, not just traditional preference, but actual safety requirement. Someone discovered empirically that dried bay tasted good and caused no problems, while fresh bay caused digestive upset. The knowledge preserved through recipe specifications, safety encoded in cooking instructions. Bay leaves also don't break down during cooking, maintaining physical structure even after hours of simmering. This means they must be removed before eating or risk choking hazard. The same robust structure that preserves flavor through long cooking also creates physical danger if consumed. Benefit and risk from single property, context determining outcome. Saffron requires 150 flowers to produce 1 gram of spice. Each flower providing only 3 tiny stigmas that must be hand-harvested during a brief autumn morning window when flowers open. This extraordinary labor intensity, thousands of hand movements for negligible yield makes saffron the world's most expensive spice, worth more per ounce than gold. Human patience transformed into crimson threads, time compressed into flavor. This value persists because saffron's chemistry, particularly safranal and crocin, cannot be synthesized economically or replicated by other plants. You cannot fake saffron. Attempts to substitute turmeric or safflower fail immediately to trained palates. The unique compounds justify the price through irreplaceability. When nothing else works, scarcity determines value. Ancient Persians valued saffron so highly they used it in royal fabrics, creating robes dyed saffron yellow as symbols of ultimate luxury. The same threads, flavoring rice, also colored clothing, edibility, and beauty dwelling in identical molecules. A spice expensive enough to wear, a dye precious enough to eat, value transcending category. Wintergreen contains methyl salicylate, chemically similar to aspirin. The compound provides genuine pain relief and anti-inflammatory effects when consumed or applied topically. Native Americans chewed wintergreen leaves for headaches and muscle pain, discovering aspirin-like medicine centuries before chemists synthesized acetylsalicylic acid. The forest pharmacy provided what laboratories would later manufacture. This chemical similarity isn't coincidence. Both wintergreen and willowbark aspirin's original source evolved salicylates as defensive compounds. Different plant families independently discovered that salicylic acid derivatives deter herbivores and fungi. Humans noticed these plants had medicinal effects and used them empirically, later discovering the shared chemistry explaining why unrelated plants worked similarly. Wintergreen flavor in candy comes mostly from synthetic methyl salicylate, now the natural extraction being expensive and supply limited. When you taste wintergreen, you're often experiencing factory-made molecules identical to plant-made ones. Nature's recipe reproduced industrially, chemistry becoming interchangeable between biology and manufacturing. The flavor divorced from the plant, molecular identity mattering more than origin. Sassafras was once the primary flavoring in root beer until the FDA banned it in 1960. The ban targeted safrala compound in sassafras root. After studies showed it caused liver cancer in rats at high doses. An American cultural icon, the taste of summer childhood, suddenly illegal. One molecule's toxicology ending centuries of use overnight. But context matters. Indigenous peoples used sassafras for millennia without apparent liver cancer epidemics, suggesting dosage and frequency matter enormously. The rats received concentrations no human would consume through occasional root beer. Still, regulatory caution prevailed to remove the possible carcinogen entirely, rather than calculate acceptable exposure limits. Safety through elimination. Modern root beer uses artificial sassafras flavor, or saffrol-free sassafras extracts, preserving taste while removing questioned compound. The flavor persists as molecular ghost chemistry, maintaining cultural continuity after the plant itself was exiled. We remember sassafras through synthetic substitutes, taste outliving its source. Calendula petals are edible and were historically called poor man's saffron because they color food yellow like real saffron. The color comes from carotenoids, particularly lutein, which provide the golden hue but none of saffron's flavor or aroma. It's visual substitution only, color replacing chemistry, appearance compensating for missing taste. This substitution reveals economic realities. Saffron was impossibly expensive for common people, but color still mattered in food presentation. Calendula provided affordable yellow, maintaining visual expectations when authentic ingredients exceeded budgets. The compromise preserved appearances while acknowledging limitations. Calendula also has genuine wound healing properties. The same carotenoids providing color also reduce inflammation and promote tissue repair when applied topically. Medieval herbalists used calendula salves for cuts and burns. Modern research confirms anti-inflammatory and antimicrobial effects. The poor man's saffron was rich in its own chemistry, valuable for different reasons than its namesake. Anise and fennel tastes nearly identical, but come from completely unrelated plant families. Both produce anethol, the compound creating licorice flavor through convergent evolution. Different genetic pathways separate evolutionary histories, identical molecules. Chemistry constrains possibilities, making certain solutions inevitable, regardless of how evolution arrives at them. This convergence meant multiple cultures independently discovered licorice-flavored plants, incorporating them into regional cuisines without knowing of each other's parallel discoveries. Mediterranean peoples used fennel, Middle Eastern cultures used anise. Chinese medicine employed star anisole, finding similar flavors through different plants. Taste convergence, creating cultural convergence. The identical flavor creates culinary interchangeability. You can substitute anise for fennel in most recipes, and vice versa. Different plants, different growing requirements, but functionally equivalent in cooking. This redundancy benefits cuisine, providing options when one plant is unavailable. Evolution, accidentally creating backup systems. Comfrey contains allantoina compound, promoting cell proliferation so effectively that comfrey poultices demonstrably speed wound healing. Broken bones heal faster with comfrey compresses, earning it folk names like knitbone. The cell growth stimulation is real, measurable, significant. A plant that genuinely accelerates healing through chemistry, not placebo. But comfrey also contains pyrrolizidine alkaloids, liver toxins accumulating with repeated exposure. The plant heals externally while harming internally, making internal use dangerous despite centuries of tradition. Ancient herbalists didn't know about alkaloid liver toxicity, using comfrey tea freely, unknowingly causing long-term damage while treating short-term problems. This duality, powerful healer and subtle poisoner, makes comfrey emblematic of herbal medicine's complexity. Plants contain multiple compounds with different effects. Isolating benefits from harms requires understanding beyond natural equals safe. Comfrey teaches that botanical medicine demands respect, knowledge, careful dosing. Nature's pharmacy includes poisons alongside cures, sometimes in the same plant. Milk thistle's active compound silymarin specifically protects liver cells from toxins, including alcohol and industrial chemicals. The compound stabilizes liver cell membranes, preventing toxin entry, and stimulates protein synthesis, accelerating damaged tissue repair. Its targeted medicine, evolved specificity, happening to match human medical needs remarkably well. This specificity raises interesting questions. Did milk thistle evolve silymarin to protect its own cells from something, and humans coincidentally benefit? Or do plants and animals face similar cellular threats, leading to similar solutions? The answer shapes how we view plant medicine. Accident we exploit, or parallel evolution, solving shared problems. Ancient Greek physicians prescribed milk thistle for liver ailments. 2,000 years before modern pharmacology isolated silymarin, they observed empirically that people with liver problems improved after consuming milk thistle. Correct observation, missing mechanism, effective treatment. The explanation came late. The cure worked regardless. Rue was used historically in many medicinal preparations, but is now considered too toxic for internal use. The plant contains phenocoumarins that cause severe photosensitivity. Skin contact plus sunlight equals painful blistering. What ancient herbalists used medicinally, we now classify as contact poison. Understanding changed classification. The plant didn't change. This reclassification demonstrates how improved knowledge alters practice. Medieval herbalists used rue extensively, attributing healing powers. They weren't entirely wrong. Rue has antimicrobial and antispasmodic compounds, but the toxic effects, especially photodermatitis, weren't understood or connected to rue consumption. Benefits were seen, harms were missed or attributed elsewhere. Rue also appears extensively in literature as symbol of regret. Rue the day derives from this bitter herb. The plant's name became metaphor, became idiom, botanical identity, transforming into linguistic expression. That they reshape language itself. Evening primrose oil is extracted from seeds, not the plant itself, but herbalists still classify it as herbal medicine. The oil contains gamma-linolenic acid, GLA, an omega-6 fatty acid most people don't produce efficiently. Supplementation provides fatty acids needed for brain function, hormone production, inflammation regulation. The seed oil fills nutritional gaps modern diets create. This makes evening primrose oil unusual. It's treating deficiency rather than disease, supplementing missing nutrients rather than providing active medicine. The distinction matters philosophically, but practically blurs. Whether you call it food or medicine depends on perspective. The oil works either way. Native Americans used evening primrose roots as food, the whole plant for wound poultices, creating dual food medicine tradition that modern herbalism preserves. The categories overlap because the plant genuinely inhabits both nutritious enough to sustain, medicinal enough to heal. Binary classifications fail. The plant transcends them. Damiana has reputation as aphrodisiac, spanning multiple cultures. Mexican, Central American, indigenous Caribbean peoples all traditionally used it for sexual enhancement. Modern research shows minimal direct effects on libido, suggesting placebo or cultural expectation driving the reputation. Yet the tradition persists, belief maintaining practice, despite lacking pharmacological confirmation. This raises questions about herbalism and belief. Does Damiana work because people expect it to work, creating self-fulfilling prophecy? Or do subtle effects exist that our current measurement techniques miss? The line between psychological and pharmacological effects blurs in medicinal plants, especially for subjective experiences like desire or mood. Perhaps effectiveness matters more than mechanism. If Damiana tea improves sexual satisfaction through placebo effect, the improvement is still real to the person experiencing it. The mechanism explaining the benefit is philosophically interesting, but practically secondary. Herbalism sometimes succeeds despite our inability to fully explain why. Pennyroyal is powerful insect repellent. The pulgone and menthone create smell mosquitoes, and fleas strongly avoid. Historically, it was scattered in homes and woven into clothing, creating chemical barriers against pests. Simple, effective, pre-industrial pest control using botanical chemistry. But pennyroyal is also toxic, particularly to pregnant women, where it can cause miscarriage. This dual identity, insect repellent and abortifacient, made it useful and dangerous simultaneously. Women used it secretly for reproductive control throughout history. Herbalists prescribed it carefully, and authorities sometimes banned it. Politics and botany intertwining. Modern understanding recognizes pennyroyal's hepatotoxicity emerging at doses not much higher than insecticidal ones. The effective dose and toxic dose are dangerously close, making pennyroyal unsuitable for casual use. Respect for plant power, what kills insects can harm humans, emerges from chemistry, not superstition. Echinacea gained modern popularity from Native American traditional use, specifically Plains tribes, using it for infections and wounds. Early settlers observed this, adopted the practice, eventually commercialized it. What was regional indigenous medicine became global herbal supplement, traditional knowledge entering capitalist markets. But commercialization created quality problems. Many echinacea products contain minimal active compounds or wrong species. E. purpurea versus E. angustifolia versus E. pallata, each having different chemistry. The name echinacea guarantees nothing about content or potency. Capitalism diluted tradition through careless production. Research on echinacea's immune effects shows mixed results. Some studies find benefits, others don't. This inconsistency probably reflects product variability more than plant ineffectiveness. When you can't control what you're testing, you can't interpret results confidently. Traditional use was specific. Modern products are ambiguous. St. John's wort effectively treats mild to moderate depression. Clinical trials show it works as well as SSR is for many patients. The compound hypericin modulates neurotransmitter levels, genuine antidepressant effects through botanical chemistry. Medicine hiding in yellow flowers, growing in roadside ditches worldwide. But St. John's wort also induces liver enzymes that metabolize many prescription drugs, making them less effective. It can deactivate birth control pills, blood thinners, HIV medications, transplant anti-rejection drugs. The herb that treats depression can inadvertently cause pregnancy, blood clots, or organ rejection by interfering with other medicines. This interaction profile makes St. John's wort poster child for natural doesn't mean safe. Active enough to treat depression means active enough to cause drug interactions. Potency cuts both ways. Effectiveness implies side effects. The plant teaches that herbal medicine requires same caution as pharmaceutical medicine, sometimes more. Arnica is widely used topically for bruises and muscle pain. The sesquiterpene lactones reduce inflammation and pain when applied to skin. Athletes use arnica gels and creams extensively, reporting faster recovery from training injuries. The external use is well established, generally safe, reasonably effective. But internal use of arnica is toxic. The same compounds that reduce inflammation externally irritate digestive tissue internally, causing nausea, vomiting, potentially dangerous reactions. The dosage form matters critically. Topical application is medicine. Internal consumption is poisoning. Route of administration determining safety. Same plant diverging between helpful and harmful. Homeopathic arnica diluted beyond containing actual molecules bypasses toxicity through elimination. Whether it retains efficacy when no actual arnica remains is hotly debated. But the popularity of homeopathic arnica demonstrates people want arnica's benefits without its risks. Dilution offering perceived safety. Neem tree provides insecticide, toothpaste, medicinal compounds, and timber one plant serving multiple industries. The compound azadirachtin disrupts insect hormone systems, preventing reproduction and feeding. It's organic pesticide approved for food crops, effective yet environmentally gentler than synthetic alternatives. This multi-purpose utility made neem sacred in Indian culture. The tree appears in religious ceremonies, traditional medicine, daily hygiene. Western medicine largely ignored it until searching for botanical pesticides, discovering what Indian culture knew intimately for millennia. Colonial dynamics in botanical knowledge, Western science arriving late to indigenous wisdom. Neem also demonstrates biopiracy, concerns Western companies patenting neem extracts and uses indigenous peoples developed over centuries. Who owns traditional knowledge? Can you patent preparation methods communities used for generations? Neem became legal battleground where herbalism intersects intellectual property law. Goldenrod is blamed for hay fever, but is actually innocent. Its pollen is too heavy to become airborne. The actual culprit is ragweed, which blooms simultaneously. Goldenrod's showy yellow flowers attract attention, while ragweed's inconspicuous flowers release wind-borne pollen, triggering allergies. Correlation without causation, guilt by association. This misidentification persists because timing and visibility align. People see goldenrod while experiencing allergies, assume causation, and perpetuate the myth. The truth: goldenrod is bepollinated with sticky pollen that doesn't travel airborne, contradicts persistent belief. Sometimes myths survive despite evidence. Goldenrod is actually medicinal. Native Americans used it for urinary tract infections. Modern research confirms anti-inflammatory and antimicrobial properties. The plant, falsely accused of causing allergies, actually treats other ailments effectively. Reputation and reality diverging. Mythology obscuring utility. Nettle stings because of hollow hair trichomes containing histamine, a serotonin. Contact breaks the hairs like hypodermic needles, injecting irritants into skin. It's chemical warfare, active defense system, protecting leaves from being eaten. The pain is deliberate, evolved deterrence through suffering. But cooked or dried nettle is safe, and nutritious heat destroys the stinging compounds, leaving behind leaves rich in iron, calcium, vitamins. What stings fresh nourishes when processed. Traditional peoples worldwide discovered this, developing cooking methods that neutralized defense chemicals while preserving nutrition. Nettle also makes surprisingly strong fiber, historically used for cloth and rope, stronger than cotton, less expensive than flax. The stinging plant provided textile materials when processed properly. Multi-utility food, medicine, fiberol from plant most people avoid touching. Witch hazel bark produces astringent compounds tannins and hamamelatanin that tighten and dry skin. This makes it useful for minor wounds, insect bites, hemorrhoids, skin irritations. The compounds literally contract tissues, reducing inflammation, stopping bleeding. Chemistry creating physical effects, molecules changing material properties of skin. This astringency is the bark's defensive chemistry. Tannins make bark taste terrible. Deter insects, prevent fungal infection. Trees evolved these compounds for protection. Humans found them useful for skincare, repurposed tree defense as human medicine. Botanical chemistry serving dual purposes across kingdoms. Commercial witch hazel extract is steam distilled, then mixed with alcohol, creating the drugstore product millions use. But the steam distillation removes the tannins. Most commercial witch hazel doesn't contain the compounds responsible for astringency. The alcohol provides some of the effect instead. Consumers buy witch hazel expecting tannins, but often receiving alcohol substitute. Marketing diverging from chemistry. Slippery elm bark becomes mucilaginous when wet, creating thick, slippery gel that coats and soothes irritated tissues. This makes it traditional remedy for sore throats, digestive inflammation, coughs. The physical coating effect is real, measurable, providing genuine symptom relief through mechanical action rather than pharmacology. But over-harvesting threatens slippery elm trees. Removing bark often kills the tree, and demand exceeds sustainable harvest. The medicine's popularity endangers its source effectiveness, creating scarcity. Several companies now use marshmallow root instead. Different plant, similar mucilaginous properties, more sustainable harvest. This sustainability crisis in herbalism raises ethical questions. Should effective traditional remedies be abandoned if harvest threatens species? Can we find alternatives that work similarly? Slippery elm demonstrates that herbalism must consider ecology alongside efficacy. Medicine that destroys its source isn't truly healing. Aloe vera gel contains over 75 active compounds, including vitamins, enzymes, minerals, sugars, lignin, saponins, salicylic acids, and amino acids. This chemical complexity makes isolating specific healing mechanisms difficult. The gel works through synergy. Multiple compounds interacting in ways single-molecule drugs don't replicate. This synergy explains why isolated aloe compounds often work less effectively than whole gel. The mixture matters. Interactions create effects greater than individual components. Its pharmaceutical chemistry lessons sometimes complex natural formulations outperform refined extracts because biological systems evolved as complete packages, not isolated ingredients. Ancient Egyptians called aloe the plant of immortality, using it in embalming and medicine. Cleopatra allegedly used aloe in beauty preparations. Alexander the Great conquered an island to secure aloe supply for treating wounded soldiers. The plant's healing reputation spans cultures and millennia, persistence suggesting genuine utility beyond placebo. Feverfew reduces migraine frequency in many users. The compound parthenolide inhibits substances triggering inflammation and blood vessel dilation in the brain. Regular consumption over weeks builds up effect, eventually reducing migraine occurrence. It's preventive medicine, chemistry, creating resistance to neurological events. But feverfew must be taken. Consistently stopping abruptly can trigger rebound headaches worse than original migraines. The plant creates dependency, the body adapting to its presence, withdrawal causing symptoms. Natural medicine demonstrating same dependency patterns as pharmaceuticals. Natural doesn't mean without side effects. Feverfew also illustrates standardization challenges in herbal medicine. Parthenolide content varies wildly between plants' genetics, growing conditions, harvest timing, all affect concentrations. A feverfew pill might contain therapeutic doses or negligible amounts. Consumers can't know. Pharmaceutical precision remains elusive in botanical products. Ginkgo biloba trees are living fossils. The species existed 270 million years ago, surviving relatively unchanged since dinosaurs. Individual trees can live over 1,000 years, making some current ginkgos potentially medieval in age. They're botanical time travelers, contemporary organisms from ancient lineages. This extraordinary survival suggests remarkable adaptability and resilience. Ginkgo survived ice ages, continental shifts, countless climate changes. The compounds helping it survive, ginkgolides and bilobalide, also affect human circulation and cognition. Whether these represent usable medicine or evolutionary coincidence remains debated. Ginkgo's cognitive effects, improved memory, better focus show mixed results in rigorous trials. Some studies find benefits, others don't. The inconsistency might reflect dosing, extraction methods, patient selection, or genuine absence of effects. Ginkgo demonstrates how ancient use doesn't guarantee modern efficacy. Tradition and science sometimes disagree. Astragalus root is cornerstone of traditional Chinese medicine, used for immune support and vitality for over 2,000 years. Modern research shows astragalus polysaccharides stimulate IMMUNE cell production and activity, genuine immunomodulatory effects through complex sugars activating cellular responses. But astragalus also demonstrates cultural specificity in herbalism. Chinese medicine uses it in specific combinations, not alone. Western herbalism often sells astragalus solo, ignoring traditional context. The plant divorced from its cultural preparation methods might work differently, synergies lost, effects altered. Traditional knowledge isn't just identifying useful plants, but knowing how to use them. Astragalus also accumulates selenium from soil, beneficial in moderation, but toxic at high doses. Where it grows matters chemically. The same species, from selenium-rich versus selenium-poor soil, are effectively different medicines. Geography becomes pharmacology, place encoding into plant chemistry. Ashwagandha means smell of horse in Sanskrit, referring to the root's odor and traditional belief that consuming it imparts horse-like strength and vitality. This Ayurvedic staple reduces cortisol levels measurably. Genuine anti-stress effects through hypothalamic pituitary adrenal axis modulation. The name reveals cultural values. Horses represented strength, vitality, virility in ancient India. Naming the plant after horses communicated expected effects metaphorically. The medicine becomes symbol. The symbol guides use. Language encoding pharmacology through metaphor. Modern stress culture embraced ashwagandha, enthusiastically adaptogen supplements everywhere. Wellness culture adopting ancient medicine, but rapid commercialization created quality issues and sustainability concerns. Indian ashwagandha populations face harvesting pressure. Adulteration is common. Ancient medicine meeting modern markets creates predictable problems. Licorice root is 50 times sweeter than sugar because of glycyrrhizina, compound activating sweet receptors intensely. This makes licorice candy's flavor distinctive, unlike any other plant. But glycyrrhizin also affects mineralocorticoid receptors, potentially raising blood pressure, depleting potassium, causing edema with excessive consumption. This dual identity, candy and cardiovascular risk, makes licorice interesting pharmacologically. The compound creating pleasant sweetness also disrupts electrolyte balance. Enjoying licorice candy occasionally poses minimal risk. Consuming large amounts regularly can cause hypertension. Dose makes the poison again. Traditional Chinese medicine uses licorice in many formulas, not primarily as medicine, but as harmonizer, balancing other herbs. This function isn't well understood chemically, but might involve glycyrrhizin, affecting absorption or metabolism of companion herbs. The synergy thinking in traditional medicine challenges Western reductionism. Kava root produces cavalactones compounds, creating relaxation, reduced anxiety, mild euphoria, without cognitive impairment. Pacific Islander cultures consumed kava ceremonially for millennia. The drink facilitating social bonding while maintaining mental clarity. Alcohol alternative, with different neurological profile. But kava also caused hepatotoxicity in some users, liver damage serious enough that several countries banned it. The cause remains unclear. Wrong plant parts used, adulterants, alcohol extraction versus traditional water extraction, genetic susceptibility. The safety depends on variables we don't fully understand. This uncertainty demonstrates herbalism's challenge. Traditional use was safe. Modern commercial use caused problems. Something changed. Preparation, plant parts, quality, frequency. Until we know, risk persists. Ancient wisdom doesn't automatically transfer to modern contexts. Details matter enormously. Closing reflection. And so our journey through the herb garden draws to a gentle, close friend. We've wandered among plants that heal and harm, flavor and poison, nourish and intoxicate, sometimes all at once. Chemistry refusing to honor our convenient categories. We've discovered that herbs are not simple. They're not merely natural or safe by virtue of growing from soil rather than being manufactured in laboratories. They're complex chemical factories, each species producing dozens or hundreds of bioactive compounds, molecules that can heal wounds and damage livers, ease anxiety and trigger photosensitivity, improve memory and interfere with medications. They evolved these compounds for their own survival, not for human benefit. Yet we've learned to harness their chemistry, repurposing defensive toxins as medicines, turning insect repellents into flavors, finding nourishment in plants that sting. The herbs we've explored tonight carry human history in their leaves and roots. Every culture that ever existed found plants growing nearby and learned through observation, trial and error, and yes, sometimes suffering, which plants helped and which harmed. This knowledge accumulated across thousands of generations, preserved in recipes and remedies, encoded in cultural practices and grandmothers' instructions. We inherit this wisdom perfect, sometimes wrong, but often surprisingly accurate given the tools available. Modern science arrives late to this ancient conversation between humans and plants, bringing new vocabulary, compounds and receptors, molecules and mechanisms to explain what traditional peoples knew empirically. The explanations are new, but the observations are old. Chamomile soothes because it contains apigenin binding to GABA receptors, but it soothed long before anyone knew what GABA was. The mechanism matters less than the reality. Sometimes plants help. Yet this journey also revealed dangers. Natural doesn't mean harmless. Potent enough to heal means potent enough to harm. Comfrey that speeds bone healing also damages livers. St. John's wort that treats depression also deactivates birth control. Pennyroyal that repels mosquitoes also causes miscarriages. The same chemistry creates benefits and risks, effects and side effects, medicine and poison. Only dose and context determine which. This complexity demands respect, not fear, but respect. Herbs are powerful precisely because they're complex, because they contain multiple active compounds interacting in ways we're only beginning to understand. They deserve the same careful consideration we give pharmaceuticals, the same attention to dosing, the same awareness of interactions, the same acknowledgement that powerful medicine requires knowledge and caution. But perhaps the deepest lesson from our herb garden is about relationships. These plants evolved for millions of years before humans existed, developing their chemistry to solve their survival problems, deterring insects, preventing fungal infection, outcompeting neighbors, attracting pollinators. We arrived recently, in evolutionary terms, and discovered that their solutions sometimes address our problems too. Not because plants care about us, but because biology sometimes solves similar challenges with similar chemistry. This creates odd partnerships. We plant their seeds, tend their growth, protect them from competitors, ensure their reproduction behaviors that look like agriculture but function like mutualism. The plants get propagated far beyond their natural range. We get food, medicine, and flavor. Both species benefit. Over millennia, we've shaped each other. We've selected plants with chemistry we prefer, and plants have adapted to conditions we create. Neither fully wild nor fully domestic, herbs occupy the borderland between nature and culture, growing in that fertile space where human needs meet plant survival. So as you drift toward sleep tonight, perhaps you'll think differently about the herbs in your kitchen. The mint spreading through your garden, the chamomile tea cooling on your nightstand. They're not mere ingredients or decorations. They're living beings with their own evolutionary histories, their own chemical strategies for survival, their own complexity and mystery. They've been shaping human history while we thought we were simply cooking dinner or making medicine. The basil on your windowsill contains ancient wisdom written in molecules, solutions to problems that existed before humans, chemistry that happens to help us too. The rosemary growing outside holds memories, not metaphorically, but chemically. Compounds that genuinely improve how your brain stores and retrieves information. The ginger in your pantry stores months of tropical sunlight compressed into pungent root. Energy accumulated slowly, released in your cooking. Every herb connects you to deep time, to the millions of years evolution spent developing these chemicals, to the thousands of years humans spent learning to use them, to the countless gardens and gatherers and cooks and healers who preserved this knowledge, carrying it forward so you could benefit from their accumulated wisdom. When you add thyme to your soup, or drink mint tea, or crush lavender between your fingers, you are participating in practices older than civilization, simple acts connecting you to the long chain of humans who found help in plants. And there's wonder in that, genuine wonder that plants growing in cracks in sidewalks contain compounds that reduce inflammation, improve sleep, fight bacteria that antibiotics cannot touch. Wonder that evolution, working blindly through natural selection, created such useful chemistry without intention or foresight. Wonder that humans, through patient observation across generations, learned to access this chemistry without understanding it, preserving what worked through cultural memory. The herb garden is laboratory and library, pharmacy and history book, growing quietly, asking little, offering much. It teaches that medicine can grow from soil, that food and pharmacy overlap, that the most powerful things are often the simplest leaves and roots and flowers, sunlight and water transformed into molecules that heal. So rest now, dear friend. Let these botanical stories settle into your mind like seeds in soil, taking root slowly, growing quietly, emerging in unexpected moments. Let wonder replace worry, curiosity quiet into contentment. The herbs will still be there tomorrow, growing patiently, waiting to share their secrets with anyone willing to slow down and pay attention. Thank you for walking through this garden with me tonight, for lending your attention to these green beings who've walked beside humanity since before we had words to name them. May your dreams be as peaceful as a chamomile meadow, as vivid as mint's sharp clarity, as enduring as sages' ancient wisdom. Sleep well. The garden is always there, always growing, always offering its quiet gifts to those who notice. Good night.